This tutorial will give you an overview of how to graph trig functions with different amplitudes and different periods. Recall that the standard amplitude and period for sine and cosine is amplitude of 1, period of 2 pi. Tangent doesn't have an amplitude but has a period of pi, and secant and cosecant has a standard period of 2 pi and a standard, I don't want to call it amplitude, but the range is either greater than 1 or less than -1. Now, this exercise, I'm not going to go through finding periods and amplitudes. We did that in class. I'm just going to focus on graphing these functions with the calculator so that you can see how to do it. We're going to start with the first function, f of x, and I'm using just the notation x, not theta here, of 3 sine of 2x. 3 is the amplitude, and 2 pi over 2, if you use our formula, is the period. To graph this on the calculator, we hit y equals. You type in 3, the sine function, 2 times x inside the parentheses, and hit zoom 7. Notice it's stretched a little bit, the amplitude being 3, stretched from an amplitude of -3 to +3 instead of 1 to -1. Okay, and notice also the period is not 2 pi, it's kind of compressed together. The actual period would be 2 pi over 2, which would be pi. The second function, f of x equals 1/2 cosine of 3x, we're going to graph similarly on the calculator, but the amplitude is going to be 1/2, and we're going to have 3x inside the cosine, not 2x. To do that, again, hit y equals, clear out your old function. Now for the 1/2, I'm going to put 1 divided by 2. Cosine, and then 3x, close parentheses, hit zoom 7, put us in trig mode. Notice it's not stretched, it's actually compressed to the x-axis because of the 1/2. Okay, the amplitude here actually is going to be 2 pi over 3. The thing about the calculator, unlike what I showed you in class I showed you how to do the quadrants. The calculator is not going to show you exactly what those quadrants are. You got to do that manually. All the calculator is going to do is give you a quick sketch of what the graph should look like after you do it manually. The next one I'm going to do is the next function, 2 tangent of 1/2 x. Again, I hit y equals, clear out the old one, hit 2 tangent. Again, 1/2, we're going to put 1 divided by 2 x. Close the parentheses, do zoom 7. Okay, it has a standard tangent, but notice it's because of the 1/2, the asymptotes are actually stretched. Instead of a tighter S-shaped curve, it's an expanded S-shaped curve because of the 1/2. That's because the period actually goes from pi to 2, if you want to count it, it goes from pi to about 2 pi. Next one is cosecant. Again, cosecant, we're going to have to use the reciprocal function. So instead of saying 2 cosecant 2x, we're going to use 1 divided by 2 sine of 2x. So I'm going to do a y equals, clear out the old one. Because it's cosecant, I'm going to use the reciprocal function 1 over sine. We have f of x, y1 equals 1 divided by, now this whole thing has to be in parentheses so we get the full effect. So in parentheses, I'm going to put 2 sine of 2x, close parentheses, twice. So that we close, and then hit zoom 7. Notice, okay, we do have the curves in opposite quadrants. The asymptotes are going to be affected by the 2x, so it's not standard 2 pi. Actually, the asymptotes are going to be 2 pi over 2 or pi. It's kind of scrunched together, as you see. And the 2 tells us that the range is not going to be greater than 1, less than -1. The range is going to be greater than 2, less than -2. For secant, we're going to use the reciprocal function of cosine. So for the last one, again, I hit y equals, clear out the old one. I'm going to do 1 divided by, in parentheses, 3. The reciprocal of secant is cosine 4x, close the parentheses twice, hit zoom 7, and again it's even tighter. Not so much the amplitude, but it's tighter because it's not 2x, it's 4x. If I would have put a fraction in there, it would make it wider. This concludes my exercise on graphing trig functions with different amplitudes and periods on the TI-83 calculator.